Indefinite integration, problem 8. 8. Determine a integral of 4 cos 3x dx. If you differentiate sine x, you get cos of x. If you differentiate sine x, you get cos of x. If you then integrate cos of x, you get sine of x. So it's the reverse. Now, and therefore we've got cos of x. But we don't have cos of x, we've got cos of 3x. So in this case, we're going to make the 3x equals a, because that's a function of a function. So what we have now is if a equals 3x, therefore the x equals to 3. Y equals x to the power of n. Then the x equals n, x to the power n minus 1. So there's 1 here. So that would be 1 times 3. So that's 1 times 3. That's why this is 3. And then you go 1 minus 1. That would be 0. X to the power 0 is 1. So if you differentiate 3x, you get 3. Why did I differentiate 3x? Because need to replace the x with the a. So if I rewrite this, the x equals, just swapping them, the a over 3. So I'm going to replace the x here by the a over 3, and I'm going to replace 3x by a. So now I have integral of 4, I'm going to put a 4 outside, cos a dA over 3. So I've replaced 3x by a, and I've replaced the x by the a over 3. So now I can integrate this. So that would be 4 over 3 integral of cos of a dA. But if I integrate cos a, I get sine a, because if I differentiate sine x, I get cos x. If I integrate cos x, I get sine x. So if I integrate cos a, I get sine a. So that will be 4 over 3 sine a plus c, which will be 4 over 3 sine, we know what a is. A is 3x plus c. Y, if you like, y, or you can call it area under the curve, equals 4 over 3 sine 3x plus c. So that's the answer we're looking for. Part B. Again, we have something similar to what we just done. If you differentiate cos of x, we get dy dx equals minus sine of x. If we differentiate y equals sine of x, dy dx will be cos of x. If we integrate sine of x, we get minus cos of x. But then we got functions of function here. So I'm going to say let a equals 2 theta. Therefore, the theta, because a is a function of theta, will be equal to 2, because that's theta to the power of 1. 1 times 2 will be 2. Then you get theta 1 minus 1, and that'll be theta to the power of 0. Theta to the power of 0 is 1. So that's why that's 2, using that formula. So instead of y, you got a, and here you got theta, and then you got the power here is 1. But you got 2 in front of that. So that's what you got here. And then applying that process. Now I want to make theta the subject so I can replace it. So I need to rearrange this. The theta will be equal to the a over 2. So I just swap that. So bring the 2 here, bring that one there. So now I can rewrite my function here. Integral, 5 is a constant, so I'll put it outside. Sine a. The reason why I've done that, because I don't have sine theta, I have sine 2 theta. And that's a function of a function, d theta. But I don't want the theta, I want to write the theta in terms of the a. So I get the a over 2. And that can be written as 5 over 2 integral sine A dA. So that looks exactly like that. The sine A is y, and you got dA. If you integrate sine, you get minus cos. So in this case, you get 5 over 2 minus cos A plus C. And that will be equal to minus 5 over 2. Cos A is 2 theta plus C. So the final answer will be A, the area under that curve, will be minus 5 over 2 cos 2 theta plus C. And that's the answer we're looking for.